Hello everyone, this is matrix multiplication using dynamic programming. Here we try to multiply various matrices in a particular order so that the number of multiplications required to obtain the final matrix is minimal. Uh, we will try to solve this using this example where we have four matrices with us, A1, A2, A3 and A4. As we already know from the laws of matrix, if we have to multiply two matrices, then the column of the first matrix and the row of the second matrix, they need to be same. Here we see that 8 into 4 and 4 into 2. So here 4 and 4. So both are same. So A1 into A2 is possible. Again, for A2 and A3, we can see the column of A2 is equal to the row of A3. And similarly for A3 and A4, we can see the column of A3 is same as the row of A4. So they can be multiplied in a order, right? Now, there can be multiple ways we can multiply them. What I mean by that is if we look into these examples, then here we can see A3 and A4 can be multiplied first, then the result can be multiplied with A2 and the entire result can be again multiplied with A1, or we can do otherwise A1 and A2 can be multiplied first, and A3 and A4 can be multiplied separately and the results can again be multiplied, or um, we can go for the third one where A is multiplied with A2, the resultant is multiplied with A3 and the final result is multiplied with A4. However, we have to find out which one is the optimal one where we require less number of or least number of multiplications. Here we can see the first approach gives us 260, second approach gives us 204, and the third one is giving us 400 multiplications, right? So we have to go through a process to find out the solution, to find out the answer, which says the minimal number of multiplications required to get the result. Now here we already know the answer. If we do the multiplication in this approach, then 204 multiplications are required. Now the question is how to find this particular answer, how to know that this is the correct way or this is the optimal way to multiply these four matrices. So that is the question. In this example, we have, as we have taken four matrices, we have to create a particular new matrix where we put the multiplication values, the number of multiplications required. Those values are put as values in this new matrix that we will create. Okay. In rows, we have put all the matrices A1, A2, A3, A4. In the column as well, we have put all the matrices A1, A2, A3, and A4. What it signifies is, if we suppose look into 64, this value comes from multiplying A1 into A2. Similarly, for 48, this value comes from multiplying A2 with A3. Okay, so this is how we are getting the values in this matrix. So we have to fill up this, and we already know that in dynamic programming, we try to use previous suboptimal values in future ones so that the calculation required is least. Okay, we can find the result in least amount of time, okay, or least amount of steps. How do we approach this calculation? I have drawn three arrows. As you can see, this is order of computation. So first we will try to fill up these values, then we will go to the next level, and finally we will go to the final level. Now if we multiply a matrix with itself, then we have a 0 here. That means we don't require this type of calculations. We don't need to multiply one matrix with itself. Okay, so with the left diagonal that we have it has all the values 0, so 0 0 0 0. Okay, now moving on to the first calculation, a1 into a2. You can see it is a1 into a2. We need to find this value here. Initially we don't know if it is 64 or not. We don't know initially, isn't it? So we have to do the calculation. So a1 into a2, we have 8 into 4 for a1 and 4 into 2 for a2. Now this multiplication is possible because the column of A1 is equal to the row of A2. Okay, so how do you find the number of multiplications required to find the answer? What we do is we take the extreme values, okay, in the multiplication, and then we take the common values as the last multiplying value. Okay, so 8 into 2 into 4. Okay, you can also do the other way. You can write 8 into 4 into 2. However, I find it more convenient for me to write in this fashion. I always take the extreme values and then take the middle common value. Okay, so 8 into 2 into 4. Now, when we do the multiplication, we get 64 here. Then once we get the value, we can put it in the matrix. Then we move on to the next one, which is A2 and A3. Okay, A2 and A3. Now for A2 and A3, similarly, we have to take the extreme values 4 and 6 and then multiply it with the common value 2. So 4 into 6 into 2, we get 48. So we put 48 in the right place. Then finally we have A3 and A4. So for A3 and A4, we again have extreme values 2 and 5 and the common value is 6. So 2 into 5 into 6, we get 60 and we put 60 here. So this was the first step. This was the first level, in fact, in this matrix. So we have the values here, 64, 48 and 60. Now we move on to the next level where we have A1, A3. Now what do you mean by A1 and A3 is you start from A1 and you go up to A3. Okay, we already know that we have 4 matrices. So if I have to go from A1 to A3, it will be A1, then A2 and A3. All have to be together, isn't it? If we don't put them together, then of course we will not have the common values. So from that logic also, we know that if I have to go from A1 to A3, then A2 will also come in between so that the laws are maintained. Okay, the multiplication law is maintained. Now, when we go from A1 to A3, there are two possibilities. You can see left hand side and right hand side. It is possible that we first multiply A1 into A2 and the result is multiplied with A3, or we can do otherwise. We can multiply A2 and A3 and then multiply the result with A1. So there are two different possibilities which I have written here. Now for A1 into A2, then with A3, how we do is for A1 and A2 we already have the result. So if you look into the extreme left column, we have seen the calculation is already done. So we have 64 here. So we directly take 64. Okay. Now once we take 64 for the next calculation, now we also have to write down the dimension of A1 into A2. That means the result that I got from A1 into A2, that will also be a matrix and that matrix will also have a dimension. And we know the dimension because from the calculation we see that if I have A1 into A2, then since 4 is common, it will be eliminated. So final matrix that we have will have 8 rows and 2 columns, isn't it? So that's why I've written 8 rows and 2 columns. Okay, because this whole result will be a new matrix and it will have a dimension and that dimension is 8 into 2. And for A3, we already know it is 2 into 6. It is written here. So we have 2 into 6. So in the next step, we have 8 into 2 as one matrix and 2 into 6 as another matrix. Okay. For the calculation, to find out the number of multiplication when we multiply these two matrices, we have to go for calculation. I've already told you how I do it. We take the extreme values 8 and 6 and then take the common value 2. So we have 8 into 6 into 2. I've written it here. Also, for obtaining A1 into A2, we already know that 64 multiplications were required. So 64 is written because we have already done a prior multiplication. So this 64 comes from the initial multiplication that we did where we multiplied A1 into A2. And to find out the next level of multiplication, we have to do this calculation, which is 8 into 6 into 2. So 8 into 6 into 2 is giving us 96. So 64 plus 96 is giving 160 and this is 160 written here. Now there is another way we can do here. Okay, sorry for this. 160 is written here, but the decision is not yet taken. Okay, so pardon me. This 160 remains here. We have to go for the other way of multiplying as well. Then decide what value should come here. Okay, so this is though it is 160 because when we do the other way we get 240 and 160 is lesser than 240. That's why we put 160 here. Still, the explanation has to be completed. So in the right hand side, you can see we have A1 into A2 into A3 in bracket. So for A2 into A3, we have already done the calculation before. We know that 48 multiplications were required. So I've written 48 here with an arrow. And since we have got a new matrix after multiplying A2 into A3, the dimension of this comes from here. which is 4 into 6, because as I told you before, the middle value gets eliminated. Okay, so we have 4 into 6 here. Okay, so the new multiplication will require two matrices. One is for A1, and A1 we already know it is 8 into 4. It is 8 into 4, and the matrix obtained from the calculation of A into 3 is 4 into 6. So since these two new matrices are available, we have to do calculation. The extreme values will be taken and the middle value will be multiplied with it. So 8 into 6 into 4. So 8 into 6 into 4. And since 48 number of multiplications were already required for A into 3, that will be also added. So we have 48 plus 8 into 6 into 4. Now when we do the further calculation, we have 48 plus 192 and it gives us 240. Now we have to decide which value should come to the matrix. So if I do this way, the left hand side way, then it is 160, and if we do the right hand side way, it is 240. We have to take the minimal value. So the minimal value is 160, so we put that value in the matrix. Okay. Now moving on to the next one, which is A2 up to A4. Now for this calculation, we know that anything that comes in between A2 and A4, they also have to be taken. Now A2 up to A4, we see that A3 also comes on the way. So A3 also has to be taken. Why? Because these values have to be common. Okay. The column of A2 equal to row of A3. The column of A3 has to be same as row of A4. Okay. So that's why all of them has to be taken. So for A2 and A4, we do further calculation. So when we do further calculation, you can see again the same thing. Okay, you can do it two different ways. One is A2 into A3. The result will be again with A4, and A2 into A3 into A4 in bracket. Okay, there are two ways we can do this. Same calculation has to be done for them as well. For A2 into A3, A2 into A3 we know 48 steps, so this is 48 steps. Then we do the calculation for the two new matrices available, so that gives us 120. So 48 from the earlier value plus 120 gives us 168. Similarly for A2 into A3 into A4 in bracket, A3 into A4 is already done before. The value comes from this calculation, so 60 comes here, plus the two new matrices, they have to be multiplied, and the value comes from 4 into 5, the extreme values, into 2, the common value, and this gives us 40. So 60 plus 40 gives us 100. Now we have to decide which value out of these two will go to the matrix. Since 100 is smaller than 168, you can see 100 is written in the matrix. Okay, so for 160 and 240, 160 was minimum, so it came here. And again for the next value, 168 and 100 is minimum, so 100 has come to the matrix. Okay, now we move on to the final step that has to be done, which is A into A4. Now we know that if I have to start from A1 and go up to A4, we also have to take A2 and A3. Same thing, the column of first matrix and row of second matrix, they have to be same. So 4 and 4 are same, 2 and 2 are same, 6 and 6 are same, right? So if we have to go for multiplication from A to A4, we have to go in a particular order. So that is A1 into A2 into A3 into A4. Okay. So while doing this, there are three approaches. I have already told you, this is one way, this is another way, and this is the third way possible. So we start from A1, go up to A4. We start from A1, go up to A4. We start from A1, go up to A4. Okay, in the first approach, A3 and A4 will be multiplied first, result will be multiplied with A2, and the entire result will be multiplied with A1. Or we can do things separately. A1 and A2 will be separately multiplied, A3 and A4 will be separately multiplied, and the resultant will be multiplied. Or we can go this way, A1 into A2, the result with A3, and the entire result with A4. Okay. Here again you see that you can use previous values from previous calculation. So this is the beauty of dynamic programming. We don't need to compute from scratch for a new calculation. Okay, for a new step of calculation, we don't need to again do the computation from the scratch. We can take previous values already obtained. Now A2 into A3 into A4, for this particular part, we have already found the result. So you can see, you can take these values from here. We required 100. So we already have 100 here. So 100 is taken. And then the two new matrices, A1 we already know it is 8 into 4. A1 is already 8 into 4. So that is there. And for this calculation, for this calculation, we can find the values from here. Now, there is a question here. We can also go for A2 into A3 and the result with A4, isn't it? If we look closely, we could have also done either way. We could have gone for A2 and A3 first and the result with A4. But we are saving time here. Why we are saving time? Because if we have to go from A2 to A4, we already know from the previous steps the best possible way is the right hand side. So in exam, you will save a lot of time to find the result. Okay, you don't need to go for two approaches again. We already know the optimal solution, suboptimal solution. So we have directly written it here. So that means actually there are not three steps. There are multiple steps possible. For this, you have two different steps. For this, you have two different steps, not steps, basically possibilities. But we are taking the correct one. It will save your time as well. It will give you the correct result. Okay. So here we have 100 steps with us, and so it is 100 written. Again, we also know that the dimension that comes after this calculation is 4 into 5. So I have written 4 into 5, and A1 we already know 8 into 4. So 8 plus 5 into 4 will give you 160, and 100 is already there. So it is 260. For this one, it is a straightforward calculation. A1 into A2 is already done before. A1 into A2 is already done before, and A3 and A4 is already done before. So you take the values 60, 64 and 60. So 64 and 60. Okay, so they are already there. Plus the multiplication of the two new matrices, which is 8 into 5 into 2. So 8 into 5 into 2. So it becomes 80, and we have 124 from earlier calculations. So we have 204. And finally, for the third approach, we have A1 to A3 and then with A4. So A1 into A3, A1 into A3, there are two different ways possible, but we already found a minimal uh, while using this approach. So we have 160 here. So we will go for A1 into A2 first, then the result will be multiplied with A3. So A1 into A2 and the result is multiplied with A3. So this approach gives you 160 calculations. A4 dimension is already 6 into 5. So we have 6 into 5 here. Now 8 into 5 into common value 6. So 8 into 5 into 6 gives you 240. And the earlier calculation of A1 into A2 and the result with A3 is 160. So 160 is already here. So 160 plus 240 will give you 400. Okay. So finally, we have three different results with us: 260, 204, and 400. Since we have already seen the results, we know that 204 is the minimal value, and we can write down 204 as the final answer. So this was the expectation. The question, if arises of this type, it will ask you to find out the way we have to multiply the four matrices so that the number of computation or the number of multiplication required is minimal. And here we see that if we go for this particular approach, that is A1 into A2 separately, then A3 into A4 separately, and then multiplying the results, we get the least amount of multiplications required to get the answer. So this is matrix multiplication using dynamic programming. Okay, so thank you very much.